In this video of cell stoichiometry, we're going to be using Faraday's law to solve for the time required to plate out a set amount of material. So the question we'll be working with today is how long must a 15 amp current be applied to a copper 2 solution to plate out 20 grams of solid copper? And as always, we'll be starting with our half reaction. So a copper 2 solution contains copper 2 plus ions. Those copper 2 plus ions will gain 2 electrons to plate out solid copper. So we have a 2-to-1 mole ratio for our copper ions. Now we're going to start on our actual mathematics. So we're going to start with that 20 grams of solid copper. We want to turn that into moles of copper. Grams isn't super useful in a stoichiometric problem. So we're going to do that by dividing by the molar mass. So we know that 1 mole of copper has a mass of 63.55 grams. So here we have solved for moles of copper, and these grams cancel. Next up, we're going to turn moles of copper into moles of electrons. That allows us to kind of access that charge component, which will get us to time. So we know that for 1 mole of copper that we produce, we're going to use 2 moles of electrons. That's going to cancel our moles of copper, and we now have moles of electrons in our stoichiometric problem. Next up, we're going to use Faraday's constant. So to go from moles of electrons to charge, we want to use Faraday's constant, where we know 1 mole of electrons has a charge of 96,500 coulombs. Our moles of electrons will cancel, and we now have coulombs. We're almost there, so to get to time from this stage, we want to divide by the current, because current is coulombs per second. So if we have 15.0 coulombs in 1 second of time, passing a single point in our reaction, those coulombs will cancel, and we will be left with seconds. So our math here, 20 divided by 63.55 times 2 times 96,500 divided by 15. Oof, we will be running this cell for a long time. To get out 20 grams of copper, we'll need to run this cell for 4,049 seconds, or if we want to put that into hours, that's going to be 1.12 hours.